Good morning. I'm Jim Green, Director of Planetary Science, and we're going to talk about the wonders of small bodies. And they really make some really incredibly big discoveries. In reality, you know, small bodies are not all created equal. Let me see if I can get to my first slide. All right, there we go. And they can tell us an enormous amount about a number of things, from the origin of the solar system to bringing material at an early phase in the Hadean and back to the Earth and volatiles. They can trace what's happening in the rearrangement of the solar system. We still have an active solar system spraying material all over the place. And of course, they're hazards, but in the long run, they may be enormous resources for us. So small bodies, in terms of how they accrete to be able to build bigger bodies, is really all about developing planets, going from dust into planetesimals, into protoplanets, and then planets, colliding all the time, creating objects such as the moon. And then, okay, let's do this. Sorry. And then we have missions that indeed have an opportunity to scour this area looking for small bodies. And indeed, past the snow line, these small bodies are now more volatile and rich in terms of water and methane and other types of gases. And as they come inward, we're able to interrogate them. You know, one of the planetary scientists, actually, Hal Levison, said, if you want to solve a crime, going to the crime scene, you look at the blood spatters, and that's really what the small bodies are all about. Now, we've been to quite a few small bodies, not as many as we like. This is a wonderful little overview done by the Planetary Society. And here's Vesta, and then you have, which is really a protoplanet. And we believe that because it has been differentiated. And then there's an array of smaller bodies that are, in fact, sometimes just rubble piles, the very beginning of the accretion event. Well, Dawn was at Vesta for more than a year, and here's a beautiful set of observations from Dawn where the color shows the mineralogy, and you can see how varied it is, and it's because of the impacts that have occurred. But one of the things that Dawn found was that it has been differentiated. There's really a core where there's a nickel and iron concentration that, as this body formed, that material melted and then sunk to the center. And the core size on Vesta is about 220 kilometers in size. Now, over time in the asteroid belt, some of these differentiated bodies continually were bombarded. And one in particular that we're quite interested in has been bombarded after it differentiated to the point where the outer layers have been stripped. And this particular body is called Psyche, and we have a mission that's going to Psyche. Let me see if I can get the next one here. All right. And that mission is called, of course, Psyche, and it's going to a metal world. We can determine that from its spectral spectra that we receive. And its core size is very comparable to what Vesta is all about. Can you imagine going to a differentiated core? I mean, we can't get to anywhere near the core of our planet, and here's a core that we can go to and investigate. We can look at how potentially its outer surface was formed, perhaps supporting currents that generated magnetic fields. Some really fundamental things that we want to look at, and the Psyche mission can help us do that. Also, missions like the JAXA Martian moons explorers going to Phobos and Deimos to determine their origin, whether they are captured asteroids or indeed material that is accreted in place that actually is started during the time Mars was accreted. Could be indeed in JAXA that's going on. So let's go to the next slide. I'm going to let you run that if you can. All right. Another thing that small bodies indeed can give us that's really exciting is a rebirth. After planets are formed after they cool down, after they go through the Hadean period, where do they get their volatiles? A lot of times those volatiles are just baked away. And so things that come back in, next slide please, after that major cool down are really objects that we want to know about. And we have a mission. JAXA does too. This one is Hayabusa II. It's going to a carbonaceous chondrite. This is a charcoal-like object in terms of its reflectivity. It's very dark, but it has what we believe are potentially amino acids. We believe it has a significant amount of water, and it's those kind of objects, next slide please, that we want to go back to and take a look at. Another one that is very similar to that is Bannu, and this is the one that NASA's OSIRIS-REx mission is going to. Next slide please. So in addition, we now believe through computer modeling and how we analyze and look at exoplanets and how all those things seem to be connected, that we're understanding better what's happened in our solar system. And we believe that early on, all our giant planets and terrestrial planets actually formed closer to the sun than they are today. And through gravitational interactions, Jupiter moved inward, the outer planets moved outward, well beyond 20 or 15 astronomical units where all these original planets were formed. And that caused a lot of the small bodies to move inward. And then as they settled down, perhaps captured at L1, or sorry, captured at L4 or L5 at Jupiter, next slide please, maybe can tell us what those initial rearrangement of our planets was all about. And we have a mission, it's called Lucy, and it's going to L4 and L5 to interrogate those small bodies we call Trojans. There is almost 1,000 of these out there. And in all likelihood, there's more as we get out and take a good look at it. Next slide, please. Now, in addition to that, comets, like Rosetta, we stayed at Rosetta. ESA did a fabulous job of that. NASA had a number of instruments on the main spacecraft. And indeed, as these comets come inward, they continually spray material into the inner part of the solar system. Look at that, from carbon-rich ammonias and methanes, an enormous amount of dust, and our planets move through that and continue to sweep it up. When we look at exoplanets and we look at solar systems and we want to determine if those solar systems are still active, we need to be looking for zodiacal dust. We need to be looking for objects like this that continually seed those inner planets. Next slide, please. Now, of course, we're taking a good look at the hazards that are associated with these small bodies. There's the well-known asteroid belt, the asteroid belt that exists between Mars and Jupiter. These are not planets that were blown to pieces and these are the rubble. This is actually a region where a planet was trying to form. And in fact, gravitationally, because of Jupiter, they are continually kept apart. Now, there's gravitational interactions between these bodies and Jupiter, along with these bodies and Mars, which throw them inward in addition to throwing them outward. Next slide. And that produces, once again, hazards. Here's an overview of the orbits of small bodies. We call these near-Earth objects. They cross our orbit, many of them, and they can indeed in the future provide us with opportunities of destruction, if you will. So we're constantly on the lookout for that. Next slide, please. And then finally, as this shows, we monitor this. This is impacts that have occurred, what we call bolides, as these objects come into the atmosphere. We see them, we note them, and in the last 15 or so years, you can see the magnitude of many of these, and it can be quite extensive. Chelyabinsk was only a 17-meter asteroid that came in and then broke up in the as an airburst, but there are much bigger ones out there. Next slide, please. And then finally, resources. We know there are all types of metals and major resources that are out there. There's quite a bit of discussion going on right now about how they might be used into the future. And indeed, the more we know about them, the more we have an opportunity to leverage and use them and create potentially places where we can leverage this material to build structures in space and to go further. And that's it. Next slide should end that. Here's the final overview. Once again, small bodies can tell us about origin of our planets as they build and bringing life to them, how the solar system was rearranged, the fact that it's still very active today, depositing many organics in the inner part of the solar system, also providing us hazards, but it also looks forward to the resources that they can provide. Thank you very much.